169. We are starting with ratios, so I want you to review first and do the 2 questions at the bottom of the page. Read the word problem, mark your text, and answer them. You have about 2 minutes, and then we will go over it. All right, let's look at these 2 problems. Laquan put $15 in savings this week. This was 3 more than the amount of he put in savings last week. How much did Laquan put in savings last week? So who can tell me how I'm going to solve this problem? $15 minus $3 gives me $12. So he put $12 last week. Make sense? Good. Let's look at the next one. Joanne bought 3 times as many books as Mitchell at the book fair. If Mitchell bought 5 books, how many books did Joanne buy? What am I going to do to solve this one?
Multiply 3 times 5.
It says 3 times, so I am multiplying 5 times 3, and that gives me 15. She bought 15 books. Any questions? Those should have been simple, guys. All right, next page. This one is a thinking problem. And it says the Crusaders and the Blue Jays just finished their first half of their basketball game. Predict the final score and explain your reasoning. So far at halftime, that is their score. What do you think the final score will be? This is your thinking and your reasoning, not your neighbors. If everybody at your table finishes, before we go over it, you may compare answers. But right now, you are thinking and writing on your own. You have about 3 minutes. Go for it.
So who has an answer for me? What do you think, Lena?
I think that maybe it would be like plus 20s so the Crusaders will still be a 10 ahead of the Blue Jays, but
Interesting. So you think it's going to be 50 to 40? Okay. So Crusaders 50, Blue Jays 40. They will stay 20 points ahead. Yeah, thank you. I did say 40. 10 points ahead. 10 points ahead. So we have a different answer? And?
I think they will at 59 and 61 because games are better when they have game-winning shots.
So you think the Blue Jays are going to come back and win?
Yes.
Okay. Interesting prediction. So what makes you think the Blue Jays are going to outscore them so much, besides being a game-winning shot?
Huh?
What makes you think they're going to outscore them so much? Because you're giving them now 41 points. They only scored 20 in the first.
Yeah, the Crusaders might have tried too hard, so maybe they're now exhausted.
Okay. Riker?
I think this says those are the points that they got halftime. The other half is going to be the halftime points times 2.
So what did you say?
So the Crusaders would be 60 points and the Blue Jays would be 40 points.
Crusaders 60, Blue Jays 40.
I think the same thing. I put those numbers, but I meant something close to it.
So we're just going to double the points in the second half. Hold on, guys. Okay, Ben.
I think it's going to be like 52 to 46 because in basketball, you're never exact. And so that means in basketball, the Blue Jays could have an insane comeback and make it Crusaders 40, Blue Jays 75. I don't know. But unless and if it stays at the right rate, then it might be. I think it's about going to be 52-46. Crusaders winning unless they go Dolphins versus Broncos and go like 100-40.
No, that's a lot of reasoning. But guys, I love that Ben brought so much into that, because he's saying, okay, mathematically these two answers make sense, but real world, it almost never works out exactly that, right? And that's part of the problem with making predictions, especially in stuff like sporting events. Because Ant made I think it was Ant that made the good point of, you know, the Crusaders came out really hard. They're probably tired, so they may not score as many in the second. So that was good reasoning too. So you guys we can't take too much longer. I know there's a lot of hands, but we've got some really good ones to base our conversation off of, which is mathematically, these are really the two answers we were looking for. But realistically, I really loved Ben's whole discussion as well. That realistically, it doesn't always work out mathematically. However, when we're looking at it mathematically and making predictions, we want to have some basis for it. And the good thing to me is you guys actually hit our two major themes for today. Alina used additive reasoning. She said, okay, well, they were 10 points apart. They're probably going to stay 10 points apart. So given that, we'll say they're going to each score another 20. Riker used multiplicative reasoning. He said, well, here's where they started. They have a whole nother half. We'll just multiply those by 2 and figure out what that difference is going to be. So that right there is one of the huge concepts we're going to be talking about today, which is additive and multiplicative reasoning. Okay? So go to page 171. Guys, quiet down, please. So we have two predictions. You can see they're both right. Okay? Robina is looking at it. She says, I think the final score will double the score at halftime. Aaron says, I think the Crusaders will play hard enough to stay 10 points ahead of the Blue Jays. So describe the reasoning that they each used, and based on the predictions, which team scored more points in the second half. So I'm going to give you a hint. The answer to part A is not the weather. It's these two words here. Which one do you think is which? Look at their numbers, look at their thought process, but then we also need to answer part B. So tell me which one is using additive, which one is using multiplicative reasoning, and then tell me, look at part B and reflect on the data. Tell me which one is actually happening.
And make sure you're adding those vocabulary to your vocabulary sheet.
Okay, guys, looking at how they were comparing the scores, if you look at the vocabulary they use, it should make it really easy to figure out which one is which, right? Robina is saying it's going to double. So is that additive or multiplicative? Multiplicative. So Robina is using multiplicative reasoning. Which by default kind of tells you what the other one is, but the key is they're going to stay 10 points ahead. So that's staying very constant, right? It's always a plus 10. So that is going to be additive reasoning. So we actually could have changed those names, and we could have used our class and said that Alina was using additive reasoning, where Riker was using multiplicative reasoning, right? So based on the two predictions, which team scored more points in the second half? What do you think?
So technically, the Crusaders,
Did you know she invited a whole group to y'all's house for Thanksgiving?
So you're saying Robina's prediction had them scoring more, right? Which team did you say scored more? Crusaders, okay? Because it asked which team, right? So the Crusaders would score more based on her reasoning. Is this making sense? Can you see the differences in the reasonings? Okay? Guys, this is actually a really important concept. Mrs. McShann already talked to you guys about how important ratios are. Understanding these concepts literally builds basically the rest of our 6th grade curriculum. It is easy if you understand the concepts. If you don't get the concepts, this is going to get nightmarish. Okay, we do need to have our highlighters. So grab your marking pens. We have 2 of our first vocabulary terms for this new module. That is, now that we've already talked about it, we're going to give it the name. So we have, quiet down please. We have our additive reasoning. Focuses on the use of addition and subtraction for comparisons. Multiplicative reasoning focuses on the use of multiplication and division. So go ahead and highlight those. It actually makes sense when you look at it just from the words that are used. Additive using addition and subtraction, multiplicative reasoning using multiplication and division. Which, if you really think about the deeper definitions, they're still very closely related, because what is multiplication? Repeated addition. What is division? Repeated subtraction. Okay? So they are still closely related, but you'll need to look at how the different things are happening to understand. We already answered part 2 on this one, so we're going to skip that. So we have this whole age scenario talking between Vicky and her nephew Benjamin. We want you guys to look, and you need to make a judgment on who is correct, because we're not giving you a hint this time. So read it out. Say who is right. Is Vicky correct about how their ages change? Hello. Oh, I went back a page. Okay. Is Vicky correct about how their age changed? Or is Benjamin correct in thinking that he will eventually be older than his aunt? And explain your reasoning. So go through the scenario, see if what they're saying makes sense, and see who is correct. We'll give you guys about 4 minutes. Try to do it on your own, and then you can talk about it as a table. Okay, let's talk about it. Who is right? Vicky was saying, I'm 40, you're 10, I'm 4 times as old. Ben, wow, you're old. Yeah, but in 5 years, I'll be 45 and 15, then I'll be 3 times. Ben's like, I'm catching up. Because in 15 after that, I'll be 60, you'll be 30. I'll be twice as old as you. So Ben's like, wow, in enough time, I'll be older than you.
Yes.
No, why not? Riker?
Because it's started when he's a little kid, and the aunt's 50, 40. You can't, it's like magically go higher. It's saying like in 1 year, there'll be one up over a year. So then you can't just magically go higher.
So you're saying Vicky's wrong in her reasoning?
No, Biggie's right.
But if Vicky's right, how is Ben wrong?
Because, well, okay. So Ben is saying that in
Well, so the first question is about Vicky. So you're agreeing that Vicky is correct.
yes.
So Vicky is and I'm going to add a word. Vicky is mathematically correct. In her comparisons. Okay, does everybody agree with that?
Yeah.
Okay, so the issue then comes down to Ben. And your point, Riker, was that what?
Don't know the word, but it's. Yeah.
That word. Yeah. The multiplicative. Yeah. That word.
It's like if it's in 5 years, both of them are gonna age 5 years. Or whatever. So then Ben can't magically go 50 years.
Okay, So we add the same amount every time.
5.
So we add the same to both each year. Each year. So Ben will never catch her. Let alone get a hold of her. Get ahead of her. Right? Does that make sense to everybody? Oh, I can't wait for this one, Nash.
What about when Vicky dies?
Okay, so if Vicky dies, I can give you a hint. My dad died, and every July 20th, I think about my dad. In my mind, is he still the same age as when he died? No, in my mind, he's always still going to be 1 year older, even though he's dead, right? So even if she's dead, is that still going to change the age difference? Nash?
I don't know.
Does your birthday change when you die?
No.
So
No.
will he still be born, or she still be born 30 years earlier than him?
Yes.
And they'll always be 30 years different.
Okay. Let's go to our next page.
Good. All right, so this table represents statements between Vicky and Benjamin. Let V represent Vicky's age and B represent Benjamin's age. So let's do the first one together and we'll talk about the directions. It says, today I'm 40 years old and you're 10. So they said V is 40, B is 10. So V equals Ben's age plus 30. Yes? So are they using additive or multiplicative reasoning in this problem? It is additive because they're adding, yes? Make sense? Good. I want you to do the rest of the table. Determine if they are doing additive reasoning or multiplicative reasoning. And then we will come back and talk about it. I also want you to answer A and B at the bottom. You have about 5 minutes. Go for it. This. All right, I'm 4 times as old as you are. So V equals 40, B equals 10, and V equals 4B. What does 4B mean I'm doing? I am multiplying. So is that additive or multiplicative? There we go. All right, 5. Yeah, but in 5 years, I'll be 45 and you'll be 15. So V equals 45, B equals 15, and V equals B plus 30. Additive or multiplicative? All right, then I will only be 3 times as old as you. V equals 45, B equals 15, V equals 3B. Additive or multiplicative? Multiplicative. All right. And 15 years after that, I'll be 60 and you'll be 30. So V equals 60, B equals 30, V equals B plus 30. Additive or multiplicative? And then I'll only be twice as old as you. V equals 60, B equals 30, V equals 2B. Additive or multiplicative? All right, so let's look at B. At any point in this age scenario, which relationship does not change? What doesn't change in the scenario?
30 years older than me.
That Vicky is always 30 years older than, was it Ben? Benjamin. That never changes, right? All right, let's look at the next page. Comparing quantities. Got Guys, I don't talk over people well. The school colors at Riverview Middle School are a shade of green and white. The art teacher, Mr. Wraith, knows that to get the correct color of green, it takes 3 parts blue paint to every 2 parts yellow paint. These are important words, just so you know, to every. There are different ways to think about this relationship and make comparisons. One way is to draw a picture or a model. So they drew the 3 parts blue paint to 2 parts yellow paint. Yes? Yes. From the model, you can make comparisons of the different quantities. You can do blue to yellow. You can do yellow to blue. You can do blue to the total amount of paint cans, or yellow to the total amount of paint cans. So it says, suppose Mr. Wraith needs 2 parts blue paint and 5 parts yellow paint to make green paint. Compare the quantities of blue and yellow paint in Mr. Wraith's mixture by writing all the possible ratios for each type. So we're getting into part-to-part ratios and part-to-whole ratios. Who can tell me what they think part-to-part means? Okay, 1 part of the mixture to the other part of the mixture. In this case, what would it be?
2 to 5 or 5 to 2.
Okay. Yes, what are my parts? Blue and yellow. So that is part of my paint to part of my paint. Blue paint to yellow paint, yes? What would a part to whole ratio be?
Percentage.
Not quite.
Like part of one bucket and then a whole bucket. Like half of a yellow bucket to the whole blue bucket.
We're not going to do fractions or decimals at this point, but you're kind of there. Part to whole. Who can tell me? Eventually, yes, but not right now. What is he making? Green paint. So if I do part of that paint to the whole paint, what would that mean? I'm doing blue to green or yellow to green. So if I wanted a part to whole ratio with this, I could say I have 3 blues for every, how many greens?
3.
Look at this one. How many paints do I have in all? 5. Does that make sense? Okay, so you're writing all the part-to-part ratios you can and all the part-to-whole ratios you can, and then answering the questions underneath. Go for it.
I see a few that are struggling a little bit, so let's go back and do the vocab on this to help us understand the terms, because you really do need to understand the terminology. So you should have your highlighters / marking pens. We have 3 of our terms here. We have the ratio. A ratio is a comparison, there we go, of 2 quantities that uses division. So really when we talk about ratio, it's comparing 2 things by division. Then the ones in the first column are what we call part-to-part ratios. Those part-to-parts are comparing the individual quantities. In other words, I'm comparing the yellows and the blues. That is a part-to-part. We also have what we call part-to-whole ratios. In those, we're comparing one of the parts to the total number of parts. Does that help? So when we say part-to-part, we're saying what is the blue to the yellow. The other thing we didn't really show you yet is how to write them, so let's give you an example of that. So if I'm looking at this, and I look at my picture, how many blue cans are there? 3. 2, and here's how we normally are going to write ratios. We use a colon. How many yellow parts are there? 2. That is how I would write that ratio. Does that make sense? Now, what if I wanted to look at it as yellow parts to blue parts? How would I write it? 2 to 3. What if I wanted to look at blue to the total? So how many blues are there? 3. How many total cans of paint are there? How many yellow parts are there? 2. How many total parts are there? Does that make sense? Hold on, I hear a couple no's. Who's saying no? Logan, what doesn't make sense? Comparing the two. Literally, all you're doing is writing the numbers to compare them.
Blue and yellow.
I'm comparing blue, and I can count. There's 3 of them. The colon is saying this is what I'm comparing it to. The yellow is 2. So, a couple key concepts. Number 1, the colon is basically taking the part of the 2, or telling me dividing the 2 parts that I'm comparing. Your order is important. Whatever is listed first has to have that number first. So because it says blue first, 3 has to be first. When it says yellow first, 2 has to be first. So however you're reading it in English, you need to translate it directly into math by using the numbers for it. Yes?
Make it like, for example, like 4 to 1.
What would the 4 to 1 be?
4 blue, 1.
You could, but then that wouldn't be the proper green for this school, right? But you can't change it because here it was 2 to 3, right? Now they're saying, okay, now he needs 2 to 5 to make green. It's going to be a different color of green. It's going to be a different shade.
You have to use the initial thing they gave you. You can't just change it if you want to.
Correct. So you have to use the numbers that are given to you for the ratios. So you're going to do part to part and part to whole. I'll give you a hint. You should have 2 for each of those. And then you tell me about what the differences are between those. Okay, starting on the part-to-part ratios. So we're now at 2 parts blue, 5 parts yellow. So I could do 2 blue to 5 yellow. I could do 5 yellow to 2 blue. Part to whole, I could do 2 blue to 7 total. Or I could do 5 yellow to 7 total. What's 2 plus 5?
7 total pink cans.
Okay, so what is the difference in the part to part?
But that's what you mean, like the answer?
What's the difference?
5.
Then? That's not the difference. No. What's the difference between those ratios?
It's like the same thing, but instead the order is kind of...
The order is flop, right? So the order is reversed. Or we could talk about them being reciprocals. But all we're doing is reversing the order, right? Reciprocal? Reciprocal. Reciprocal is if, like, what the reciprocal of 1/5 is 5 over 1. When you flip the numbers over. What is the difference between the part to whole ratios? The primary color is completely different, right?
Rowan, are we getting any of this now?
I'm going to add in, but the total is the same.
Ash, are we getting any of this now?
Guys, if it's getting on the board, you should be writing it in your books. And you'll see this. When I've written part-to-part ratios, an easy way to get an extra one is just flip them, turn them around. Because in a part-to-part, you're using the same parts, you're just going to put them in a different order. That being said, the order matters, guys. You're going to hear this a lot as we talk about ratios. The way I've written it has to reflect the way it was written in English. Okay? When I'm doing part to wholes, though, it's going to give me all the information I need. If I know there's only 2 things, I know that's 2 to 7 total, that should tell me what the other part is, correct? You'll need to be able to use that information moving forward. Samaya? After Ben does. Yes? Okay? And it's the same word. Still ratio. Yep. Okay, let's go to our next one. Do you want to run this way or you want me to?
It's not happening.
Mm-hmm.
I mean, you're still in part to whole. Yes, it is.
Okay. I know. So we're going to find ratios all around us, guys. We're going to start by looking at different quantities right here in our room. So we're going to help you out. Ms. McShannon and I will each count our own sides of the room for our comparisons. But we're going to look at the number of students wearing glasses to the number not wearing. So raise your hand if you are wearing glasses today. 1, 2, 3, 4, 5. I have 6. Ms. McShannon?
7.
So we have 13. Raise your hand if you are not wearing glasses today. Raise your hand if you're not wearing glasses. Rashad? 17.
I don't know, because half of them aren't raising their hands, and I don't know what this person's doing. Raise your hands if you are not wearing glasses. Isaac, that includes you. Thank you.
Yeah, Isaac.
15.
So 32. So now that we have our baseline, we should be able to figure out the rest of our ratios, right? So I know that I have 13 wearing glasses to 32 not wearing glasses.
Stop tapping.
So now if I want to go to not wearing glasses to wearing glasses, what would that ratio be?
13.
Good job, 32 to 13. Now I'm going to change it a little bit. We're going to look at a part to whole ratio. So I'm going to say wearing glasses to the total number. So what would that one look like? 13 to 45. Because there's 13 that are wearing glasses. And if I add the wearing to not wearing, that gives me a total of 45 people. Because I counted myself, I don't think Miss McShann did. So now can we do
Because I'm wearing something, just not glasses.
not wearing to the total? That one would be 32 to 45. Is it starting to make sense?
Yes.
Do you understand where the numbers are coming from and how we display them?
Yes.
Okay. So we're not going to do the second part because of time. We're down to about 12 minutes. So instead we're going to go to this one.
Tapping.
So we're going to do another look at ratios. Middle school is going to do a new mascot, either Tigers or Lions. So each homeroom analyzed the results and reported the results in a different way. So we have 4 classrooms, 6A, 6B, 7A, 7B. Each of them have reported them. I want you to describe the meaning of each statement, identify which describe ratios, and whether the ratios are part to part or part to whole. I'm not going to worry too much about this one because of time. I just want you to go through, tell me, is that a ratio? And if it is, what type of ratio is it? So you're going to have 4 answers, 6A, 6B, 7A, 7B. Is it a ratio? If so, what type? Go. Our first one, they say the votes for the Tigers outnumbered the votes for the Lions by a ratio of 240 to 160. Should have been easy. Is that a ratio? Yes. What kind? So it is a ratio. It is a part to part. Because it's talking about which part was Tigers, which part was Lions. There were 80 more votes for Tigers than Lions. Is that a ratio? No. Not a ratio. What about our next one? The votes for Tigers outnumbered the votes by Lions by a ratio of 3 to 2.
Yes.
Yes. What kind? And our final one, 3 out of 5 votes were for Tigers. Is that a ratio?
Yes.
Yes. What kind?
Part to whole.
That is a part to whole. So a couple quick notes on that. 3 out of 5 votes for Tigers. So do we know how many votes were for the Lions?
2. Yes.
Yes, 2. Because one big piece on this is understanding there's only two options, right? Tigers and lions. That allows me to make really good inferences based on the data that's given. Secondly, in 6A, it said it's 240 to 160. That's 400. But in 7A, it was 3 to 2. That's 5.
Yeah.
Does that make sense? What do you think happened?
One class has more students than the other class.
400 to 5?
Yeah, that, I mean, wouldn't it be for, like, smarter kids?
Then?
They decreases simplified it.
They simplified it. Quite frankly, we will normally simplify, guys. You have him there.
He said he's here. He's just not in here. Where is he?
He hasn't been here the whole period.
I'm gonna go walk around for a minute.
Okay, so the other two they simplified. So both the 7th grade ones simplified their ratios. Make sense? Okay. We haven't covered this yet. Well, I kind of did, but there are two major ways that there's really three major ways to write a fraction. So let's put this kind of at the bottom. Where do we have the most space? We're going to just kind of put it here in the sideline. So writing ratios. Do your best. There's really three primary ways we're going to write ratios. The first one is we use a colon. So I'm going to say, for example, 3 to 2. That normally, when we write ratios, that is the format we are going to use, is a colon. However, and you'll see this as we continue on, we're going to be doing math with our ratios. In order to do that, we need to switch it to the actual definition, which is it's a comparison of two things by division. So whatever my first number is becomes my numerator. Whatever my second number is becomes my denominator. So we will write it as a fraction. That's going to allow us to do things mathematically with the information that they're giving us in ratios. The final way is actually just using words. So I could say, for example, 3 to 2. Or I could say like 3 for every 2. There's a whole bunch of different ways we can use words to compare them. But those are our three primary ways of doing ratios. Questions?
I have lots of them right now.
I do too. But that's a whole different thing. Okay. So, unfortunately, we're down to like 5 minutes. So let's go to our homework real quick. So let's go to page 181. What?
He was skipping class.
Okay, we're on page 181. Describe two ratios in the real world. Write about at least one part to whole and one part to part. Guys, we gave you an example. Glasses to not glasses. Find anything, I don't care. Blondes to brunettes, whatever you want. But take two, write about them. You don't have to have numbers. You can make them up. That's okay. You should not be putting stuff away right now, Ben. You should have this out right now taking notes for how to do this homework. And Ben's not the only one. He was just the most obvious. Okay, Lewis Brothers joined the club. They get free movies on a list they pre-select. They pick the first 10 movies for their list by choosing their favorite type. John put 5 sports, then 3 sci-fi, and then 2 comedies. So write the ratio in colon and fractional form. We just covered that. So every one of these should have 2 answers. One in fraction form, one in the colon form. And then identify which of the ratios are part to part and which are part to whole. So you're doing 2 ratios for each one, but then for each category, A, B, C, D, which ones are part to part, which ones are part to whole. Second page, pretty easy. Write the percent that represents the shaded part of each grid. Each one is a whole. So we haven't talked about percents. We didn't get to that part of the lesson. So I'll give you the first one as an example. How much did they shade? 2. It's out of 100. Percent means out of 100. So I put the percent sign. It's that easy, guys. So there should be a really easy homework for you guys. This one should literally take you about 5 minutes. Any questions on anything we covered or anything on the homework? Kiana?
So percent always means 100?
Percent always means. Percent by definition is out of 100. Any other questions? Okay. Good luck, guys.